To our deliberations and giving a human touch. Thanks again. Now I would request Professor S.K. Dash, President Indian Meteorology Society and Council Member of WMO, to deliver presidential address.
Thank you very much. And of the dais, participants of this conference, my dear students, very good morning to all of you. First of all, I would like to thank Professor Ahmad to invite me to this prestigious university and also the Geography Department, which is the oldest in this part of the world, that is Asia. I feel it an honor to be here. I had visited AMU long back. I came to IIT JEE examination because I retired from IIT Delhi. I am still connected, but not formally. And that time I thought that I must visit AMU, so I had a round and I was very impressed with the buildings and the campus. It's really very old and prestigious university, so I definitely feel honored to be here on this occasion. I congratulate Professor Ahmad and also the Geography Department to have this conference on a very, very important topic, that is the climate change and its impact. I think all of you know that there are different opinions on climate change. About 30-40 years back, many scientists, renowned scientists in the world, were not believing that the climate is changing. But it's based on the physics, the simple physics. That is, there are certain gases in the atmosphere which are called the greenhouse gases, and most important is the carbon dioxide, which has the property of allowing the solar energy to come in, solar radiation, and not to allow the secondary radiation from the surface of the earth to go out. It's like greenhouse effect. That's why the greenhouse gas name came. And it traps in other words, you can say that it traps the energy from the surface of the earth, because you know that every object radiates. So Earth's surface also radiates, like sun, and the radiation from the Earth's surface doesn't go out from the atmosphere because of gases like carbon dioxide. There are also methane, nitrous oxide, CFC. These are called the greenhouse gases. And also it is found that this carbon dioxide, which was 285 ppm, very small quantity in the atmosphere 100 years back, has become 412 or 13 today. These are constantly measured, and we believe the observations. There is no manipulation of the data. So another thing also says that if you look at the proxy data even, the surface temperature alone, the mean temperature of the surface all over the globe, if you look at its variation and carbon dioxide variation, then both are changing. Both have been changing, cyclic. There is a cyclic means not really periodicity, but decreases, increases. It lasts thousands of years even, from proxy data and so on. Then what is the issue? It's true that the nature changes. Change is the constant. All of us change, and nature also changes. So there is a natural part to this change of temperature. And also there is a natural part to this change of carbon dioxide. But the worry or the discussion about the climate change is not the natural change part, but is the part made by the human beings. Because I don't have that graph to show. If you IPCC report, if you just go to the Google and search for, you will find a large peak in 100 years. Earlier there has been changing about around a mean value, but in 100 years there's a sudden peak of carbon dioxide, sudden peak of the mean temperature of the surface of the earth. That is the worry. So we're not bothering about or discussing about the change made by the nature, but we are discussing about the change made by the human being, activities of the human being. And that is connected to the why carbon dioxide is there in the last 100 years? Obviously because of the industrialization. And if you look back to our ancestors, they were living in nature, and human being being the most intelligent animal on the surface of the earth, we try to have safe life, convenient life, and now you can say the luxurious life. We didn't bother about the use of the natural resources. That's the whole problem. And if you recollect the famous statement by father of the nation, Mahatma Gandhi, this nature has adequate, or you can say sufficient for our need, but not enough for our greed. And we have become greedy. And that is because you are exploiting the nature and using a lot of energy which is not necessary. So we cannot have second opinion about this. There are different implications of the climate change, and today it is accepted all over the world that the temperature of the surface of the earth has been increasing to the extent of 1 degree, 0.8, 0.9, or you can say around 1 degree. It has increased, which is based on observation. Many countries have their weather observatories. Almost all countries have weather observatories that the meteorological department they call National Weather Services, and they have their data, and also satellite data are available now. Everywhere you will find that there has been rise in the temperature of the earth. As a science topic, this is the most important science topic discussed all over the world. When we were children, that time we hardly found any topic in the newspaper about the discussion about the climate or any science topic related to nature. Today, every newspaper, daily newspaper you see, you find something about some changes and extreme weather events. These are reality. Snow melting is a controversial topic. Glacier melting is a controversial topic. And some places there are some changes, as Professor Sharma mentioned, there is no change, and a lot of false news, or you can say sensitive matter, came out in the IPCC report. So those things apart, we have to almost agree that all over the world people are concerned about the changes made in the weather, and that has become because of the change in the mean pattern of the climate. You see, weather is the manifestation of the climate, you can say, or perturbation part on the mean field, that is the climate. If the mean temperature is changing, and then there is more evaporation, and there is more moisture available in the atmosphere, obviously there will be change in the circulation pattern, and daily weather will change. And that has been happening all over the world. Evidences are there. And just like the Australian fire in California, or our super cyclones, and heavy rainfall incidents, unprecedented heavy rainfall incidents. These about 1905, before 1905 probably, scientists didn't have the idea that the weather and climate is based on the physical principles, like conservation of energy and this equation, momentum equation, thermodynamic equation. These are the fundamental equations in physics. And in 1905 it was realized by a scientist that atmosphere being a fluid, it has to obey these fundamental laws. And from that day onwards, there have been a lot of progress in understanding these equations and applying, in case of the atmosphere, through the modeling. Only last 40, 50 years back, a model could have been established, because to run a model based on these equations, there are 5 fundamental equations, and these 5 fundamental equations, if you solve, you will get the future values of the parameters. Climatic parameters means what? Temperature, humidity in the atmosphere, wind is a vector quantity, it has directions, and these parameters, surface pressure is the fifth time-dependent parameter. They are connected by 5 equations. So it's all basic principles of physics and science. And to solve these equations, you need these values at t is equal to 0. The initial value condition as also a boundary value problem. So you can solve these if you get the initial conditions. But the only problem is that the initial conditions are coming from the observations, meteorological observations. Only problem is that these are not linear equations, not like a straight line. If you change one, the other will change. They're all connected to each other. We call that nonlinear phenomena, nonlinear equations. And to solve these equations, you have to adopt simpler methods, that is, numerical schemes are there, and then comes the calculations involved. That is why I need supercomputer. So the progress in computing industry, that as the more and more powerful computers came out, and more instruments came out to take the observations throughout the atmosphere, and from satellite also through radars, in addition to the surface observations, it was possible to have better data, better methodology to solve these nonlinear equations, and get faster results because of the supercomputer. That is the progress in weather and climate science. To the extent that today, at any time scale, you can get the values. Short range for 1 day, 2 days, 3 days, 4 days. These are called the weather forecast. And you can also even get for months value, mean month values, and what will happen after 30 years, 40 years. These are all fundamental science. Still, why the people do not believe the weather forecast, and why the climate projections, which are given by about 30 models in the world through IPCC, why those are not believed? It's not the problem of the scientist. It is the limitation of the science. This is not particle physics. This is not nuclear physics. There is no exactness, because you can all understand that, as I told, it depends on the initial value and the method you are solving this complicated equation. You cannot get 100% true values. There will be some value, uncertainty you can call it. There will be some uncertainty because the initial data you are giving, there will be some inaccuracy in those initial data. Every instrument has limitations. And the most important problem here is that in the mathematical model, we are doing some approximations to solve this complicated equation. Had it been straight line equation, you could have got exact value. So this is the limitation of science, and the climate scientists have been working very hard to have better and better methods, and also the when computing I think these quantum computers will come up in future. We are hoping that the results will be still better. And we have progressed a lot in the weather forecasting. all over the world, even in India today, people have started believing the forecast given for 3 to 4 days. But as I told, you have to take it to believe that value with the scientific thought in mind that this science is not exact. And whatever values will come up, there will be some probability. It may be 60% true, it may be 70% true, it may be 10% true. If it is 10% true, in that case, you have to take the chance that you will say that this forecast may not be correct. If it is announced that there is possibility of rainfall in Aligarh and the possibility is 20%, 30%, you may not believe that. But if you say that is 80% chance of rainfall, you should believe it more. This type of approach you have to have. You have to understand the science, the limitation in science, and the work being done. Question comes about the climate. Climate projections are available by 30 models, 30 or more models, and there are global models and there are regional models also, a small region. And global models, the values come because, as I told, is connected to computer, solving the equations on the computer. These global models, the distance at which you get the projected values is more. But in regional model, because you have the same computing power, you can solve for a smaller region at a high resolution. You can even get up to 5 kilometer, 10 kilometer, this type of values. These fields are available even up to end of the century. Here again comes how far you will believe, how far you will not believe. Because all models are different. But one fact is very true. Even if the 30 models, the rainfall projected, what will happen after 30 years or 40 years or end of the century, different. Temperature values are different. There is no model which is giving same temperature or decrease in temperature. All models are giving the surface temperature will rise and the rise will be more. Will you not believe that? This is based on physics, the solution of the equations. So you have to know what part of this will believe, what part will not believe, because it's necessary for the policy. There is more and more demand from the governments to know about from the scientists. Some time back we were shy of giving these values in 10 years range, 20 years range, 30 years range, because you know that the errors will be more. We know that if we say that what will happen after 10 years, the mean value in the month of July, August, September, October, the chances of those values occurring is less. But today we cannot shy about, because the governments are asking that today the science is being for the society. Any project is given by these governments all over the world, they are saying how it will benefit the society, otherwise no funding. So we cannot say that the values will be bad, so we are trying to improve ourselves and trying to get useful results from the models. We know that all the results of temperature will be very good in models, but we know that rainfall is tricky. Rainfall is a very difficult parameter to be simulated by the model. So if I say that after 30 years there will be too much of rainfall in this area or all over India, my getting wrong, chances of getting wrong will be more. But I can say that yes, temperature will rise. We have examined a lot of models. There is no doubt in this model, there is no what you call difference in this part, that one thing, night temperature is rising and will rise more than the day temperature. That means in the winter season there will be warmer nights than today in the winter season. And the rise in temperature in the night, minimum temperature in the night would be more than the rise in temperature in the daytime. That doesn't mean that day will be cooler. Day temperature will rise, night temperature will rise. But if you look at the rate of rise, so these parts of things we have to say robust evidence, a robust result from the model. Similarly, monsoon. Indian summer monsoon rainfall will decrease in the future this is another indication that many models are today showing this type of things. So these type of robust results we have to take up and take to the policy decision maker. They are asking for this type of results. We should not give everything which is coming out of the model. There comes so my urge to these students, for the younger generation, is that the most emerging science today is the climate science, which you cannot avoid because it is going to affect the society to a large extent. There is no doubt about that. And you have to take up these subjects because you will get the thrill of doing science, which is valuable to the society. And in that context, those who are exactly, you see, climate science is interdisciplinary. There is no barrier. Physics, chemistry, mathematics, geography, computer science, even biological science, chemistry people, these are all, it covers all science in a way. And it covers all aspects of the society also. It's a very beautiful science. And fortunately today, a lot of data are available, observational data all over the world free, and model data, as I told, so many model data, you can churn this data and learn a lot. That is one part. You can give useful information to the second part is you can, if you want to go in details with the model, you can work hard and enhance the quality of the model so that you will do a great contribution to the scientific community. Which models will give better results, improving the model part. Third part, even those are not interested in science but in technology, the crux of the matter in the climate science is the energy. You have to go for alternative energy, source of energy, clean energy or green energy, solar energy, wind energy, geothermal energy. That is the future. You have to go away, do away with this because the geopolitics. Why the international agreements on climate is not accepted by the country? Geopolitics, economics in a way involved. America has developed a lot. Their per capita energy consumption is much more. Their per capita global emission is much more. They are using a lot of energy. They may not bother. But a country like India has to bother because we have poor people, we have to improve, we have to depend on industry, we do not have technology for alternative source of energy. We have to depend on coal and petroleum products, so we cannot agree all the international agreements because that will affect the people. So there is a complicated affair. Economics is too much involved. You cannot, the governments, still governments are taking steps. All governments in India have been taking steps in the climate direction to agree with the international convention. But it cannot be to that extent because we have to take up the poverty level of our people, go up economically. So there is a challenge to the young people, those who want to go to technology, how to find alternate source of energy, more efficient source of energy. And even those who want to have independent, they're enterprising, they want to entrepreneur, they have also a challenge, that is how to how to clean the environment, how to get energy from the waste. If you can read articles, it's not that I am telling from my side, there are a lot of articles available today. And best thing is the Google, as you know, you have to be very careful about the false news though. So I have a request to the young scientists and the students that in whichever field you want to go, you have a challenge for climate today. Whatever field you go, you can connect to the climate because that will affect society. It is interdisciplinary and it affects all aspects of society. I think I was asked to tell for 10-15 minutes, so I told that. And go deep into the science. And I wish all the success for this conference. I heard that Professor Ahmad has so many conferences in the last 1 or 2 years. So he's very dynamic. So under his leadership, I think can have more conferences, and I think today the best source of learning is not the curriculum exactly, but extracurricular activities. These are extracurricular activities where you learn more, interact with the people, get a chance to discuss. And today's youngsters don't want to read books alone. I think that is true. You don't have to read only books. You read the fundamental things, but also engage yourself in scientific thought and try to help the society through the development of science. With these words, I wish all the success to this conference, and namaskar to all.